Okay, so a little bit more about the axis of symmetry. Remember, the axis of symmetry cuts your parabola in half. It goes through the vertex. So since the parabola is symmetric, points on either leg, here's a word you don't use on a regular basis, equidistant. It means they're the same distance from the vertex, okay? If you're given 2 points, right, 2 points that have the same y value, meaning they're at the same height, we can find the value of the axis of symmetry using this formula. Here it is. So for axis of symmetry, I would say have this on your study sheet, okay? It's x is equal to, we take the first x value we know, we take the second x value we know, and we divide that in half. Okay, so that's the formula. You should probably have that on your study sheet. Remember, make a vertex, right? Make sure you put a point, and this is the axis of symmetry. That's what we're talking about. So no matter where, okay, guys, no matter where, if you pick 2 x values that have the same y value, okay, watch this part. The distance from this to the center will be the same as the distance from this other point to the center. So as long as you're at the same height, you can always assume that. So we just add the x values, divide it in half, and then you'll find the midpoint, right? Like the distance right in the middle. So no matter how you slice it, right, the distance is always going to be the same. This is very, very helpful, because if you know something over here and it's 5 units to the center, it will take another 5 units to get you to the other side, on the other side of the leg, right? Anyways, keep going. Here are just some basic examples. So determine the equation of the axis of symmetry. Use both sets of points. So technically, this is my x1 and this is my x2, right? So if you consider these ones here, imagine they're both at the same height, so you're marking that. You can see it visually, you can tell by the y value, okay? So if we use those points, if you wanted to find the axis of symmetry, you go x1 plus x2, all of that divided by 2, so x1 is -2 plus 6 over 2. X is equal to 4 over 2. X is equal to 2. This is the equation of AOS. Would that make sense? Would that actually be something like we can observe? Where's the vertex? It's right here, right? What's the coordinate of the vertex? 2, right? 2, 3. What is the axis of symmetry? It matches the 2, right? It should. So let's highlight that with the color of your choice. But we expected it to be 2, right? We expected that. So your equation of the axis of symmetry is right here. So it's not just a point, it's an equation, okay? By the way, do you think we would get the same answer if we use these 2 x values here? 0 plus 4 is what? 4. Divide that by 2. What do you get? It's 2. Yeah, it should be. It doesn't matter which 2 points you pick. As long as they're at the same height, you're going to get the same axis of symmetry. Okay? All right. I will ask you to practice that. Just go homework here. You can try these ones. You should notice that they're both at the same height, so same formula. Just make sure you have this on your study sheet. Keep going. 13. I will call this application of axis of symmetry formula. Determine the missing x value. So you have one point, another point that is you missing the x value, and you know the vertex. Now, I wouldn't expect you to graph this to solve this question. Honestly, it should take you a minute or less than a minute to solve this one, but let's do that just for today's question. So 3, 5, and question mark 5. Vertex is 6, negative 10. So let's try this. 6, negative 10 is right about there. Three, 5 is right about there. And then we have question mark 5. Okay. This is kind of what we're observing here. This is what you should imagine. This is 3, 5. And we notice that this one is at the same height, right? This is question mark. So let's call that x2, 5. Let's do some mental math, because I don't want you to always just use the formula if you don't have to, because sometimes this might be a multiple choice question. Do we know where our axis of symmetry is right now? We know it goes right through here. And sorry, I didn't do a very good job graphing this. But to go from 3 to 6, how many units are we walking sideways to go from 3 to 6? That's 3, right? Correct? To go from 3 to 6 is 3. And so how many units do you think will it be from here to the other side? Another 3. So this will be what? 9, 5. Because if we go from 3, this is the 6 mark, remember? So from 3 to 6, right? And then another 3 gets us to 9. So we expect this to be 9. However, let's use the formula. We know that x is 6. We know that x1 is 3. We don't know what x2 is. So we have partially filled in our formula. The first thing I would like to do on this side is to get rid of the division here. So I'm going to multiply this by 2, and I'm going to multiply this by 2, allowing me to cancel. So I end up with 12. I can lose the brackets. And then you can bring this over to the other side, subtracting. So it'll be 12 minus 3 is equal to x2. So you now found the x-coordinate of that other point. By the way, we're talking 9, 5 is the point, right? Since we found that x value, now we know the exact coordinate of that second point. I guess the third point, you can say it that way if you want, right? But that's sometimes what we use the axis of symmetry for. Okay? Another one here. I'm bombarding you with, I call these like little bits and pieces that you need to be aware of. Given f of x is that's in general form, by the way. Tomorrow we're going to talk about the other forms a little bit more. Describe the direction of opening, the width, and the y-intercept of the parabola. I think that you would already know, okay? It's pointing down because a is negative. The width, what is the width? Wide or narrow? Do you remember? Have that on your study sheet. This would be a wide curve, okay? It's wide because the value itself is between 0. A is between 0 and 1. And we're talking specifically 0.02, right? That's the number I want you to look at. And the y-intercept, there's a plus 0 tagging along. The y-intercept is 0, 0. Okay? It's always 0, C, and so it's the origin, right? That's the y-intercept of this one. Now, this is something that you should have seen, but chances are you forgot how to. What does f of 3 mean? If I show you f of 3, given your f of x, what does that mean? Anybody remember? So f of x, you've got an x there, you've got an x there. If I put a number in there, what does that mean? It means that put a 3 in for x. Substitute 3 in for x. That's what that is saying. So f of 3 is basically saying 0.02, 3 squared plus 12.5 times 3. And if there had been a constant, you would add that yet, right? We don't worry about it. So this would be negative 0.02 times 9 plus 3 times 12.5. That's 37.5. So sometimes I want you to show me a little bit of work there. If you multiply these two, technically, guys, you can practice that. You type all of this into your calculator, and you get 37.32. Okay? So what did we just find, guys? When x is equal to 3, we found a point on the curve. And that specific point is x is equal to 3, y is equal to 37.32. I know it's Monday and it's first thing, right? But what calculator function would we have used to do this with our graphing calculator? Second trace what? If you know the x value, second trace value, x is equal to 3, you should get this back for your y value. It's how we find the y-intercept, okay? Okay, I'm technically f of negative 4 is next. So let's just do that real quick. I'd rather you accuse me of too many examples than not enough examples, right? So let's make a deal here. If you show me this, I'm okay. Like, you can now use your calculator and just boom, give me the final answer. I just need to know that you know what we're trying to, what I'm asking for if I give you that. So if you want to, I would type it in exactly like that, negative 0.02 brackets, negative 4, you got to use negative, okay, squared, plus 12.5, and I use brackets if there are brackets, right? So if you type it in exactly like I showed you, that's negative 50.32. So the point you found on this curve, we're still talking about the same curve, guys. you found 2 points. Technically, you could now plot these and connect them and have a parabola going. I would probably say find the vertex on top of it. Okay. All right. One more thing here. Given this, I'm going to ask you from time to time, give me what A, B, and C is. So what would you say A is equal to? 74.3, right? It's the X, this is the A value right here. So 74.3, please don't give me X squared, anything like that, just the sign and the value. B is the one that's attached to the X variable. So negative 3.75. C, therefore, is the constant. If B isn't present, right, if there's no X term, B is technically 0. If there's no constant present, C is technically 0. So you got to watch out for that. Okay, don't just say NA, because it is there. Okay, so your homework is page 8, right? Is that where the domain and range is found? Domain and range. I think page 12, there were a few questions on axis of symmetry. And I know you're not going to like me, but I'm also going to give you an AC that is very similar to the one you got over the weekend. Okay? I call these take-home ACs, take-home ACs. Okay? Now it's a magical Monday, right?